In this episode, we are going to look at hexagonal architecture. Hi, I'm Mark Bradley and welcome to Testing All the Things, a screencast in which we use live coding to demonstrate different types of testing tools and techniques. In this video, we're not going to write any code. We're going to look at the code we wrote over the previous episodes to create our book API, and we're going to draw out the architecture that we used. Hexagonal architecture. This is a way of designing applications to be loosely coupled. The idea was created by Alistair Cockburn. Let's look at the code. In the videos where we created our book API, I tried to avoid using the architectural pattern we were going to use. I wanted to concentrate on the tests we were creating. But now I think it's important we look at the architectural decisions we made. You saw how useful they were in the aid of testing each layer. Now let's look at how they can improve your applications in other ways. Hexagonal architecture is very simple to understand. There are many diagrams on the internet that show how to use it, but I thought it'd be very useful to apply it to the code we've been writing. So the first thing we should look at is the hexagon of our diagram. The hexagon doesn't actually mean anything in particular, it was just a shape that was picked. But in the centre of the hexagon is where our business logic and our business code sits. I'm going to put that in our diagram straight away. This is where the business logic sits. Okay, stretch it out a bit. We're going to start over here on the left hand side of our diagram. We're going to add a circle that sits here. Now this circle represents the implementation of our HTTP handler. If we go and look at the code, we called that the book by ISBN controller. We can link those two things together. Okay, so this is our controller. And the idea here is this controller understands HTTP and REST and JSON. And that's all it understands about our application. What comes in and out of here from the real world what comes in and out of this controller is HTTP, REST, and JSON. Those are the things it understands. It knows how to handle an incoming HTTP request, look at the URI and recognize the ISBN within the pattern of the URI, and it knows how to respond with JSON for different circumstances. That's all it understands. Not quite. There's one other thing it understands. It knows it has access to an interface. Which sits here. Sits in between our HTTP controller and our business logic layer. Like so. So we've got this interface here. In our code, we called this interface, we can see if we open up our ISBN controller, an ISBN book retriever. And that's just an interface with one function, retrieve book by ISBN. If we go back to our diagram, we label the interface. If we link that like so. So now we're starting to develop some understanding. So this ISBN book retriever is the interface to our business logic layer. Our controller layer doesn't need to understand anything that happens within here. It just needs to know that once it's got its ISBN from the request that came in, the HTTP request, once it's done its thing, it then needs to pass an ISBN over into this interface. And this interface retrieve a book for it to render into JSON and return. So that's what we have here. It's a very simple interface. In fact, I'm just going to put I here so we know that it's an interface. And then this jumps into our business logic. So our business logic is the thing that implements the function within this interface, which is retrieve book by ISBN, which we call the book manager. So if we go and label our business logic area, so this is our book manager. So it's there. Okay. So our business logic layer here is our book manager. And it knows it has to implement the interface here that sits between it and something that gives it an ISBN. So it knows it needs to return a book. It also knows it then is responsible for obtaining a book from somewhere. And this is where we start looking at the left-hand side of our screen, the right-hand side, of our screen. And this is where we start looking at the right-hand side of our screen. Our implementation, our business logic layer, takes a book repository as a dependency. And again, this is another, should have been an interface. So let's go back and maybe we could have had a refactor here, added that interface, which would have been better. And maybe we should do that. So let's go back and implement the interface stuff set up in the code. So we want to create another interface that sits here. Okay. We've got another interface that sits here. And we'll give this a name now. So we'll call it ISBN book repository. And that's going to be another interface. I'll go and create the interface in the code after this and just push it. I won't make you watch me create an interface and make those code changes. But we'll create that interface and we'll call it that. And we know that that interface is implemented by a book repository. So let's create the implementation on this side. Okay. Okay. Like that. Okay, and we're going to give that the label, and that was the book repository. Our book manager business logic layer now implements an interface it knows it has to respect, and it also makes use of an interface that it can use to obtain books, a repository, a storage solution for books. Because of the interface that we should have created, it doesn't have any knowledge of how those books are stored, how they're retrieved. It just knows that if it gives a ISBN book repository an ISBN, then a book will be returned, and it can then fulfill its interface with over here and return that book to the thing that's been asking for it. We could have done some better naming here. This could have been a refactor that we could do as well. So our book repository, again, it doesn't really give us much information by the class name. So we could have called this book repository. Instead of just book repository, we could have called it Postgres book repository or PSQL book repository to give the user of the book repository, not the user of the interface, but the user of the repository, the understanding that this book repository uses Postgres. We know now that this book repository needs to talk to something in the outside world. So let's represent that. Okay, and this is, I'll stick a label on it. PSQL. No, it doesn't fit with it now. There we go. Okay. So the book repository here is completely responsible for the communication in and out of. I'll represent that. PSQL. There we go. So this is responsible for implementing the interface, or at least one of the interfaces we know about, the ISBN book repository, and interacting with the outside world. So this shows you kind of how these hexagonal architecture diagrams relate to the code we've created. So I know we've got a bit of stuff that sits around over here, which is our application, which probably actually, imagine, sits around all of the code we've got here. But we'll ignore that. We're just looking at the details of our application, not the bootstrapping provided by the Slim framework. So hopefully you can see why this way of structuring your code and following this architectural pattern makes your code very testable. One thing that can make your code very testable is following the S of the solid principles, the single responsibility. And this is a really good way of separating out your code, so each layer has a single responsibility. So if you imagine here, but it's nice, over here the controller is responsible for handling HTTP, understanding HTTP, REST, and JSON. So not masses of stuff really sitting over here. It's just got one responsibility, and it has knowledge of one thing, passes its, once it's done its thing, it can pass an ISBN into our business logic layer. Then our business logic layer, okay, it's at this point it's very simple. Its responsibility is very low. It knows it has access to something that holds a number of books, and it can access those books by the ISBN it's been given. But if we had this business logic layer and it was responsible for the saving of books or the creation of books, then the business logic layer might also do some validation of the data that comes into it and reject books for saving if they don't have an author or they have too many numbers of pages or something like that. And then we would have another interface sitting on this hand side, which would be book storer interface. Our book repository would then implement two interfaces and interface with our database. And again, small amount of responsibility over here, sitting here. Our repository is just responsible for taking data and throwing it to its data store. In this case, a Postgres database. That covers why this way of writing code and separating code out makes testing very easy. The other thing it's really useful for is it means that because you've got your business logic that sits in the center, and business logic would be reasonably stable, okay, then my feature changes might slightly tweak the business logic layer, and yes, that would have cascading changes potentially on the controller side over here on the left, and possibly on the repository side over on the right. There might be more data need to be stored and more data be returned or something like that. But if we want to make more sweeping external architectural changes to our application, it means we can do that very simply without having to affect our business logic. So for instance, if we wanted to make some changes to the front interface, the access to our application, we can easily make these by creating something else that can obtain an ISBN and pass it through our interface into our business logic layer. So for instance, we could change the fact that this is HTTP REST to be a gRPC implementation, or it could be not gRPC, we could make it a GraphQL service. Or we could have the fact that somehow the communication is not HTTP at all, but it goes over a queue or Kafka topics or something like that. So this part here is completely interchangeable without affecting our business logic layer. And the same can also happen on kind of the back end of our SYST application, our data store. So because of the interface here, we could have all sorts of different options. If we decided we didn't want to use Postgres anymore, we want to switch out completely, we can switch out to MySQL, a different SQL database. Or we could go and say, actually, we don't want an SQL database at all, we want a NoSQL database. We want a document store, we want to go to using MongoDB or Elasticsearch. We could quite easily, again, swap out our data store, our repository of books, into a completely different technology, and our business logic would not be the wiser. All it knows is it's being given something that implements the interface that it needs to obtain books. Obviously, the example we implemented was very simple. It was just about retrieving books. But we might want, if we think about now the creation of books, and we'll keep with our HTTP REST implementation. So a book is given to us via JSON, and we can take that JSON and the HTTP request and construct the data that needs to be passed over whatever interface we create here, ISBN book creator maybe interface, and it goes into our business logic layer. Now, our business logic layer would know that it could store the book that is given into a book storer interface, and that's implemented by a book repository. Now, as we remember, we could say that our validation of the incoming book would sit within the business logic layer. And that's quite simple. But what might happen when we're creating books is we might want to do more than just store our book over here on the right hand side. We might want to notify something of our book being created. So what we might have is another interface that sits over here, so book creation notifier maybe, and that could be implemented by, again, a number of different things. We could have it sending an email to all the managers that a book has been created, or we could have an implementation that sends an SMS message or sends a Slack notification to people that a book has been created. Okay, so that's kind of power that the hexagonal architecture. It's nice, it gives you the ability to be able to swap things out very simply without having to affect your business logic, and keeps your business logic central to everything. I hope you enjoyed this walk through the architectural design of our API. I'll make the changes and add the interface we talked about, and add this diagram to the repository. See you again soon. Thank you for watching this episode of Testing All the Things. I hope you enjoyed it. If you did, please rate and review the video and subscribe to the channel. If you did not and you have any feedback, please leave a comment in the comment section of the video or contact me on Twitter @Bradle.